Eventually I'd get the right one. We're going to be working on today interest part B, the homework to do with calculating essentially questions involving money. And there are lots and lots of different questions. If you remember, I won't show you them all in detail, but remember all these formulas that we had? We're going to be using most of them again. So I guess I should just get started. So let's do a future value question. There are two kinds, ones that involve simple interest and ones that involve compound interest. So if you're doing simple interest, then the future value A is P 1 plus RT. And that's the formula that we're going to use. And when you're doing compound interest, it's going to be A P 1 plus R over N over NT. So let's look at questions where these are being used first. So first question, oops, no boundary line here, put them over there. So the first question is similar to question 1 from the homework. They're asking you for the future value. So they're asking you to find A. And in this story, you deposit $1,000, so P is $1,000. And it's in an education fund. And the interest rate is 1.7%, but we always convert it into a decimal. So it's that guy. And we're doing this for a period. Oh God, I've got Windows on top of Windows now. And we're doing this how many years? 16 years? Oh, there we are. For 16 years. Now, we're going to look at this question as if it was a simple interest question. Now, if it was a simple interest question, the amount you would pay would be P 1 plus RT. And P is 1,000. And the other two numbers we already know. And pretty much you grab a calculator and you're good to go. So I'm going to go 1,000 times, put a bracket in, 1 plus 0.017 times 16, close the brackets. And the answer I get here is that you would end up with rather disappointing $1,272. Now let's imagine it's the same question, but it's compounded, and it's compounded, let's say monthly. So you get paid monthly. Well, the formula is A P 1 plus R over N T. Now, since you get compounded monthly, that adds another variable. It adds in the N is going to be 12, right? 12 payments a month, compounded monthly, right? If it was daily, 365, right? N would be 365. Now, in this question, you're going to have $1,000, 1 plus the interest rate divided by 12. And up here is going to be 12 times 16 years. And again, I'll get my calculator, but this time it's going to be a bit more messy. 1,000 times a bracket, 1 plus the interest rate as a decimal, divided by 12, close the brackets, raised to the power, and I would put a bracket around that for safety and do 12 times 16. And we now get more money.
Professor, how do we do raise the bracket on this calculator?
You see this funny little guy here? It's called a caret button right underneath the clear. You hit that button.
Okay.
Right, so if I wanted to do 9 raised to the power of 8, it's 9 caret button 8. I have no idea why that's called a caret button, but evidently that's its name, so that's what I'm using. Are you okay with that?
Yes.
1 second.
Yeah.
So you just do the caret button, and then you just go over.
Yeah.
And then you just do
Yeah.
bracket 12 times 16.
Yeah, I'm going to show you that on the big emulator program, because it might be kind of small for you to see, and that makes it harder to figure out what on earth I'm pressing. So I'm going to do that exact same calculation a second time, but this time I'm going to be using my emulator program, which is a little bit easier. So there's that. It's a little bit bigger. I hope it is anyway. So
Yes,
here we go. 1,000. Right, 1,000 times, put a bracket in, 1 plus the interest rate. Ah, darn it. It's okay. I hit something that I shouldn't have hit. 1 plus the interest rate, 0.017, divided by the number of payments per year. In this case, it's monthly, so it's 12. Close the brackets. There's that caret button, raised to the power. I put a bracket around there just to be safe and go 12 payments over a period of 16 years and close the brackets. And now when I hit enter, you get $13,012.33. Is that a little bit clearer, the buttons, when you see it on the large one?
Yes, but when I do it, it says that I have an error. It says quit or go to.
Are you doing a TI-84 just like me?
Yeah, I got the T84 plus.
That shouldn't make any difference. Right, so let's go through it one last time, because all it needs is you to miss a bracket that you thought you put in, but you haven't. So you got 1,000 and you do a times, and you're going to do a bracket. 1 plus this guy divided by 12. Close the bracket. You done that again?
Yeah.
Right, the little caret button. Start another bracket. 12 times 16, close the bracket, and hit enter.
Okay.
Is it working this time? Still not what? This is why I dislike online. If you were in the class, I'd be right beside you and I'd be just saying, oh, look, that little button there, you press that, and I would know. But I can't kind of see what you're doing. So if it's not working, I'm kind of up a creek and I don't have a paddle. I'm not sure what to do. But is it working?
I use a different button. Could I share mine? Because I just used a I don't know if that works.
You got a TI-84?
I can't see myself.
No, but have you got a TI-84? Something else?
No, I have 60s. Or I have something else, but I figured it out. I thought maybe it would be on her calculator.
Well, if she's using a TI-84, then it probably wouldn't help. I could certainly share it, but I'm not sure what's going on.
There's like an X with a box to the right that works sometimes. I don't know. Sorry.
No, I'm pleased you're trying to help. I'm just not sure in her case is it going to help. Right, was it Jade that was having the trouble with the calculator? Can't hear anything. Okay, let's just keep going and we'll figure it out, because I'm going to be doing lots of button pressing today. So if it doesn't work for the first one, it might be working for the second one. So let's return back to our puzzles. So this is a future value question where you get money and you want to find out how much you're going to get in the future. If you did a simple interest version with the same numbers, you only get 1,200 and change. And if you did, I'm going to have to mute everybody again. Sorry about that. Get some feedback. So where was I? And if you do a compound interest monthly, in this case, you get that out. The reason why you get more money is that when you do compound interest, you get paid interest every month. And then that becomes money that you later on get paid interest on again and again and again, like the snowball effect. Now, there is a third version of that, so I guess I should have put it in. And that is when it's compounded, what they call continuously. And the formula for getting the future amount is EA equals P E to the RT. So for my third version, using the same numbers, compounded continuously, you have $1,000 E to the power of 0.017 times 16 years. So I'm now going to go to the calculator and we'll try that one. So hopefully this one will work better. Clear that out of the way. So it's going to be 1,000 times E to the power. I get E by using this button over here. So if you go second ln, you get the E to the power. You can then type in 0.017 times 16 years and close the brackets. And that answer comes out to be, just finish off writing down what it is. That answer ends up being $13.12 and 59 cents. So slightly different again. Okay, calculators, those who've been hitting these buttons, are these working out fine for you? And those who've got different calculators may have to figure out how to get the E to the power, because there will be a different version. Now, there are two ways to get E to the power. The first one uses blue button ln. I'm now going to show you the second way of doing the exact same calculation. So 1,000 times. Do you see the little blue E that's on the division symbol? If you do blue button division symbol, you get E. But you have to put in the power and the bracket yourself and then continue the same way. Yeah. So you see there's two different ways to do that. Me personally, I prefer the blue button ln. Right, so let's return to basically our questions. Are we happy about how to find future value simple interest, future value compound interest, and future value compounded continuously interest? Are we good with those three questions? Simple, compounded, in this case monthly, compounded continuously. Any questions? Are we good? I'm looking at faces and I'm not getting anything. I got
I'm
thumb.
good.
Great. I'm good to go. That's what I need. Right. So there are two kinds of future value question. The first kind of question asks you to find the future value. And that's the three that we've just done. But the other kind of question tells you the future value, and it asks you to find P, which is sometimes called, depends on the story, is sometimes called the present value. A is always future value. Sometimes P is called principal, sometimes it's called present value. It's the same thing, it's just being called different things. So far, so good? Right, so let's show you what that kind of question might look like. And I'm going to do 3 versions. So suppose the first one is you want to have $5,000 in 20 years. And you're going to be able to get an interest rate of 4% during that time. And you want to know what to start with. So how much money do I need to put in the bank so that if I get an interest rate, simple interest rate, by the way, a simple interest rate of 4% for 20 years, how much would I need to put in the bank so that at the end of that time it's worth $5,000? Well, the good news is that you use the simple interest future value formula. And you know A is 5,000. You don't know P. You know 1, obviously. You know the interest rates. And you know it's times 20. So what you have now is 5,000 P. That guy times that guy adds 1. Let's see what that is. If I go to my calculator, it's 1 plus 0.04 times 20. What does that look like? Ah, I put a bracket in. I just got a bracket similar to whoever had a problem the last time. Check that you've got the right number of brackets. You can only have 2, 4, or 6. If you've got 3 or 5, you've missed one. So let me do that guy again. 1 plus 0.04 times 20. And that guy there is 1.8. Now let me show you my mistake. I went bracket 1 plus 0.04 times 20. Okay, 1 plus 0.04 times 20, and I put a bracket in. There you go. Did you see what happened when I put a bracket that shouldn't have been there? It came up with this funny error thing that someone was mentioning earlier. So I think I may have figured out what went wrong for them. You have a bracket in the wrong place, is my best guess. Right. This is an equation, essentially. What do I do to find the missing value of P, the present value, as it's called? How do I solve that?
Divide.
Divide both sides by 1.8.
Yep. You are on top of it. And of course, I'm going to have to round off to the nearest penny because it's money. So 5,000 divided by 1.8 comes out to be approximately $2,777.78 if you round it up. So do you see how that future value can be used in 2 situations? One is I put some money away for 20 years. How much is the future value going to be? And the second question is, I want the future value to be this number. What should I start with? Which is how I did that one. Now that's a simple interest one. Let's do a compound interest one. Suppose I would like 100,000 because I'm greedy and I want to have a lot of money. And I can get an interest rate of 5%. And I'm going to do it for 30 years. Right, so I want it to be worth 100,000 in 30 years at 5%. How much money would I need to start with, right? What is P? So A, P, 1 plus R over N to power of nt, and I forgot the most obvious thing. It's going to be compounded. Oh, I did monthly the last time. What do you want me to do this time? Compounded daily, weekly, semi-annual, weekly? Okay, weekly. So if it's going to be compounded weekly, can we assume that it's 52 weeks? I think everybody will say, yeah, that's right. 52 weeks in a year. So I want it to be worth 100,000. I don't know who you are yet, because that's the guy I'm going to be finding. The interest rate, n is how many payments? 52. To the power of 52 times 30. What basically I do is I calculate this ugly mess, and the answer's going to go there. I think I'll do it on the big calculator because there's a lot of buttons to press here, and with a bit of luck, we'll figure out which one it needs to be. Right, put the thing on, clear out the other stuff. So it's got a bracket. It's a 1 plus 0.05, that's 5%, divided by 52 payments a year. Close the brackets, raise it to the power, put a little bracket in for safety, 52 times 30, 52 payments times 30 years. Close the bracket off, enter. So the number that I'm going to use is 4.4784 and some stuff. It's not unlike the earlier question. Don't I just divide both sides by this 4.4 thing that I've got here? So it's 100,000 divided by 4.4784. Go in my calculator and I'll do 100,000 divided by 4.4784, and the answer is that I'll need 22,329 and roughly 40 cents. Are we cool with that question now? You happy about how I got future value? Right, so present value actually. Have you figured out how to do it in your calculator? Because it's going to be a bit different than mine. Were you able to do the same kind of calculation in the way that your calculator needs it to be done? Taryn, I'm talking to. Yeah, great. Okay.
My number.
Well, it's better than nothing.
My number just came out different. That's why I was staring at it, because I was like trying to make sure that I put in the right number. So
Is this number here different from mine? Because
yeah,
if you make it a little bit bigger or a little bit small.
I had 22,347.37 because it was 6 rounded up.
Okay.
So I was trying to figure out what I did wrong then. But
no,
nothing.
It's just accuracy. Nothing's wrong.
Okay.
See this number here, if I had written it down with more decimal places, I would have probably got yours. Glad you brought that up. WebAssign, I fixed it now, but I didn't realize it until we had some people with issues. That your answer and my answer, for instance, were a little bit different. Agreed? It's not that we did anything wrong. You did maybe more decimal places than I did, and that's why it became out a little bit differently. You might have done a few. WebAssign is expecting a single answer, or it used to be. And you could do the entire question right, and you're 2 cents out from what it wanted, and it would say you were wrong, right? Well, I fixed it. I went into a sub-menu, and the sub-menu says, as long as you're within 1%, you must have done it right. So from now on, as you do these questions, you may not get exactly the same number that I get, but it will be, WebAssign will realize that it's an accuracy issue, not I'm doing it wrong issue. Okay? So that should help Tara. That'll actually help all of you, because I've just noticed when I was doing some of the questions, and I was just checking because I want to make sure that when I do them, they're going to work with you, that I wasn't getting the same answer that WebAssign said it should be. And I think what was going on there is that my TI-84, I think it works about 8 decimal places. But I think the people who did WebAssign must have been using a computer or something that had even more decimal places than I can do, and their answer was coming out differently. I also noticed that in at least one question, did you know that a year only has 360 days? It doesn't, but in at least one of their questions, they made it 360. Now, I don't know if that was a typo or whatever, but if they told him it was 360, I just used their number and that was fine, right? So, a little word of warning, as you're going through these questions, it used to be that you had to be perfect before WebAssign would say it's okay. Now you just need to be within 1%, and I think that's a tolerance that everybody will get correct if you hit the right ones. We've only done 2 of the 3, so let's do this one. I would like $400, and I'm going to get an interest rate of 3% compounded continuously. And I'm going to do it for 3 years and 9 months. Who knows why? But for some reason, in 3 years and 9 months from now, I want $400. And we are going to figure out what money do I need to put in the bank if I get this situation going. Think of it as pick the right formula. That's like your step 1. Right? If it's compounded continuously, pick this one. If it's compounded weekly, pick this one. If it's simple interest, pick the top one, right? Start with the right formula. Put into that formula all the things you know, and there's only going to be one thing missing every time, or otherwise the question's not fair. Now, in this case, you're told the future value. The interest rate is 3%. What's 3 years and 9 months going to turn into? And it's not 3.9. 3 years and 9 months. I heard 3.75. Now, where's that coming from? Well, think about it. If you take 9 months as a decimal, isn't it 0.75 of a year? So 3 years and 9 months, 3.75. Does that make sense? So up here, 3.75. And then it's time to do the calculator thing. I think I can do this one on this screen. It's not too big. I'm going to calculate all of this. So blue button, ln, to get e to the power. 0.03 times 3.75 years. Close the bracket, enter. And I have 1.11907. So to get P, it's going to be 400 divided by 1.11907. So 400 divided by 1.11907. And I will need to have $357.44 to the nearest penny. And that is future value questions of every possible combination I can think of. Any questions about that? Are we good? Looks like I got a good. So let me close off some windows. And I'll have a look at the homework and see how many questions actually fall into that category. I think I'll make it a little bit bigger. Okay. Oh, I made it too big. Okay, there we go. What is the future value? 16 years, 1,000 deposit. We covered that one, right? That's very similar to one of the ones I did at the start of today. Question 2 is nothing to do with that.
It still says that you're loading your screen.
It does.
Yeah,
Yeah, it
mine-
just says your screen share.
Let's try it again. How about now? Is it still say it's
Yeah, it's doing
loading?
that little- yeah, it's still doing that circle thing.
We are having technical difficulties, guys. Let me go in and close some windows and see if that helps. I've got a lot of different windows going on. Ah, here we go. Evidently, I ran out of time and it was timing me out. Is it there now?
No,
No. Okay, I'm closing the window. I'm going to go back in. And I'm not swearing. Have you all noticed I haven't swore once yet?
yeah, I noticed that.
Isn't that real? It's really good self-control. You should be amazed at how good I am at this. I don't know if it's third or fourth time lucky, but hopefully I can do it this time. Are you looking at the thing I want you to be looking at?
Nope, I see you in your background. It did it for
How about now? 107, chapter 1-1, interest part B.
I still see you.
Yeah, I'm not that interested, especially for the next hour and a half, to be seeing just me. As good looking as I am, I can understand it wouldn't be that interesting. So, okay, what am I going to do? What am I going to do? Right, you lot are going to bear with me while I close everything in sight and then go back up and open it up. The last thing I want to do is to switch off my entire computer to try and figure out why it's not doing what it's meant to be doing. I wonder if I have camera issues. That could be the case. Let's try it again. Are you looking at screen 2? And does it say 107?
Native.
No. Can you see question 1? What's the future value after 16 years? No.
It keeps wanting to switch
Nothing.
over, but then it goes back to you.
Let's try. I don't know what this is. What's this window look like?
Now,
What do you
there
see
go.
now?
I can see you now. Or the problems.
Can you see the questions?
Yes.
Okay, I don't know what I did and I'm frightened to leave this window in case I can't get it back. Let's find out where we are in the big scheme of things. Oh, that's the wrong section. I can't use that one now. It has to be the next section. I had to close it. Darn it. It needs to be this one. Are you looking at it?
Yep.
Should I be very careful here and move it over to the other screen? And then close this one and then go in and tell it to use screen 2. Are you still seeing it now?
Now I'm seeing it now.
Oh, God, that was tough. Okay. I need a joke. So let's do a joke before we even go near these questions, because they're driving me crazy, this machine right now, and I need some downtime. Who have we not picked on? Has anybody got a good joke for us?
I could Google one.
Well, you Google one. While she's Googling one, does anyone have a good joke for us that we can do right now? It has to be suitable. That's the only question. Okay, you ready for my first one? I probably told you this one, but who knows? Why don't ants catch COVID? ANTS. Why don't ants catch COVID?
Why?
Because they have antibodies.
Oh, that's okay.
Thank you. That was pretty bad. I agree. I never ever say these are good jokes, right? I say these are jokes I like. That's not the same thing. Have I told you the Canadian jokes?
No.
Do you? No? Okay. A Canadian was walking down the street of his local town and he had a crate of beer on his shoulder and he was dead happy, he was smiling. And he walked down the street and he saw his friend across the road and he waves at him and his friend waves back. And he said, his friend says, "What's that you've got on your shoulder?" And he looks and says, "Oh, it's a crate of beer for the wife." And the other guy said, "That was a good swap."
That's pretty bad.
Crate of beer for the wife. Tough crowd. Canadian. Oh, well, let's go stupid. I don't know what your humor level is like. So here's a stupid one. Why don't Canadians, no, let's rephrase that. Did you hear about the Canadian who get killed raking up the leaves?
No, I didn't know. No.
No, he fell out the tree.
Oh,
It's funny.
Bad? Is it that bad it's funny or it's just bad?
no, that's funny.
Okay. Do you know that, what's the difference between a Canadian and a canoe?
No idea.
Don't know? Canoes can tip.
Ouch.
That one was told to me quite a few years ago by somebody who worked in the restaurant. Evidently, Canadians are not very good at tipping. Okay.
Good to know.
Did you hear about? Yeah, that's evidently the stereotype, at least.
Yep.
Did you hear how Canada got its name?
Oh,
Canada used to not have a name. Canada was just described as that country to the north of America. And the president of Canada was getting, Prime Minister of Canada was getting really annoyed at this. And he goes on TV and he says, "We're fed up not having a name, so we're going to get our name today." He says, "I'm not going to do a committee, I'm just going to do it live on TV." He says, "I've got a big bag of letters of the alphabet here, and I'm randomly going to stick my hand in and bring the letter out, and whatever comes out, that's going to spell our country." And so he goes in and he brings out, he picks and goes, C, A, N, A, D, A,
I got that. I got
Yeah, I
it.
got that.
Understood. I understood that.
You got
It
it.
just took a minute to
Because they
sink
say
in.
A. Yeah.
It takes a while. Some of my jokes take a couple of years. Some of my jokes are delayed reaction jokes. So you got to imagine that if you didn't get that joke, that you did, but if you didn't get one of my jokes, you'll be driving somewhere and then suddenly you'll go, oh, Canada, I got it, right? Our last joke then. Scotsman, American, and a Polish guy. So I've changed people to insult now. We're going to insult Polish people. So Canadian, Scottish, American, and a Polish guy all die and they go to heaven. And at the bottom of the stairway, right, up to heaven in the pearly gates, and at the bottom, St. Peter is there and he looks at the list, the book, and they're not in it. And they look in and say, what's going to happen? He says, well, you're going to end up in hell. That's what happens if you don't get into heaven. That's the options. And they look at him and say, oh, come on, give us a chance. And St. Peter says, well, I feel in a good mood today. I'll give you a chance. He says, you're going to climb one step at a time up the stairway to heaven. And if you can get to the last step and you don't laugh, I'll let you into heaven. But if you step at any one of those places, if you burst out laughing or giggle or anything like that, that's it. It's over. You're going to hell. And so they all agree on it. And they got up 3 or 4 steps and he tells them the joke about Canada. And the American can't help it. He bursts out laughing. And he goes, and he disappears. And the Scotsman and the Polish guy look at him. And they get kind of serious because they know what's happened. And they, ooh, watch that. And they continue up the stairway and they get halfway. And when they get to halfway, he tells them the joke about the Canadian with the beer on his shoulder, and the Scottish guy can't help it. He bursts out laughing. And he disappears. Polish guy's the only one left, and he's really serious now, and he's jokes and jokes and jokes, and he finally gets to the second last step. And before he's even told what the joke is, the Polish guy bursts out laughing. St. Peter says, oh, come on, you were so close. What happened? And the Polish guy says, oh, I just got the first one. No.
No.
Okay. No. Okay. Well, I don't know about you, but I feel so much more relaxed than I
Well, that's
was
it.
5 minutes ago, right? So let's, fingers crossed, positive thoughts, switch over to screen 2, and we are going to see section B homework. Are we looking at section
Yes.
B homework? Oh, life is good. Life is good. Okay. I'll make it a little bit bigger and hopefully I won't do anything weird to it. Okay. So the first question is very similar to what we've done today. I'm going to talk about these guys later. These are inflation rate questions. I'm looking for another one of those questions. Okay, question 7 is a future value question. They're kind of nice here. Do you see that they've basically told you the formula you're going to use? So that's similar to what we've done today. Question 8 is another one of those. Question 9, you're going to invest $1,000 at 6% compounded continuously. Oh, no, that's not one of those. I haven't done those, sorry, take that back. Question 10 is one of the ones we've done today. 11 is one of those. 12 is one of those. Okay, we've got quite a few. So 10, 11, 12, and question 1. That looks like the ones that are similar to what we just covered. So I'm now going to leave this and talk about some of the other kinds of things that you're asked to do in that section. Question 2 from Part B homework basically asks you, sometimes the questions are so simple that you kind of talk yourself out of it. Suppose you buy a home and finance it, and the home costs you 295,000, right? But you pay $2,263.17 per month. That's called your mortgage. And you're going to do it for a 30-year mortgage. And the question is, what is the interest that you paid? Well, essentially, don't you find out how much money you paid in total and then take it away from how much you borrowed to buy the house? And that would be the interest, sometimes called the finance charge. So let's see how much you paid in total. Well, it's just a big calculation. I paid $2,263.17, 12 months for 30 years. Would you agree that's the calculation that would be the total amount of money I would have paid when my mortgage is finally over with? So it's going to be a huge amount of money. It always is. I think the last time we did this, wasn't it over $500,000? We've done one like this last time. So $2,263.17, 12 payments for 30 years. $814,741.20. And so the interest is how much you paid, take away what it cost. So it's 814,741.20, take away 295,000. And if I take that number, I've already got it in my calculator, I can just take away the 295,000 from it. I hit too many zeros there, darn it. 814,741.20. Take away 295,000. And the answer is 519,741.20. I'm getting deja vu. Did we do this question before? Okay. So it must have sneaked into part B because I think we did it and it was part A when we did it first time. But that's your answer. Okay. Moving on. Let's do some inflation questions. I know we've done some of these. Definitely from part A. Part B just goes over some of the same things. Let's find out what we are doing in this case. Say the quote, this is an example of question 3. So let's say the current rent is $500, very cheap rent. And the interest rate is 4%. And it's compounded continuously. And it's going to be, oh God. So if you stayed in the same apartment for 30 years, which I guess some people in New York might well do, right? You lived in the same place for 30 years. What would your rent have increased to? So although this is an inflation question, it's really a disguised future value question. And the formula that I'm going to use is the one where it's compounded continuously. So the future value is P E to the RT. Can you remember that was the formula for compounded continuously? And I know that right now, that guy there is the present value. Actually, it's the present rent, but we'll call it the present value. So 500 times E to the power of 0.04 times 30. Okay, what do you think it's going to cost you to rent that apartment in 30 years from now, based on not an unreasonable interest rate? 4% is not that much. You're about to be scared. I would anyway.
1,660 or whoa, 1,606
Whoa.
and 6 cents.
Right, that sounds very reasonable. Let's check it out for the rest of them then. 500 times blue button LN, interest rate for 30 years. That sounds like what you just said. I believe that is exactly what you said, wasn't it? 1660 and basically 6 cents. That is essentially an inflation question. So if ever you see an inflation question, it's a future value question. And it's typically going to be compounded continuously, but sometimes it might be compounded monthly, but more likely than not, it's going to be this fella. So since I've got this fella in front of us, and 4% is not an unreasonable interest rate, let's do another one of those inflation questions like we did before. Okay, I think last time I tried to do coffee or something, don't think anybody remembered what it was. So let's do something that hopefully everybody buys at least once every week. How much is 2% milk cost if you buy a gallon-ish? Hit the space bar, Tara, so I can get your answer. You said something, but I can't hear it.
$4.98.
Okay, so $4.98, right? Multiplied by 4%. Let's find out how much milk's going to cost in 10 years. Do you see all I do is put a 10 there, right? 10 years, 10. So $4.98. Do you think it might have doubled in price? Might only be 50% dearer. Let's see what it is. 4.98 times blue button LN, that's the E guy, 0.04 times 10, close the brackets. And in 10 years from now, it's going to cost us $7.43. Now, 10 years is not that long away. Does $7.43 seem quite expensive for milk? I mean, if you're going to drink milk, you're going to pay whatever it is, right? You can't get your own cow. That's probably unrealistic. That's inflation for you. Let's do one more inflation question. Let's do another house one. Suppose the house that you are living in and you're paying a mortgage in is $400,000. That's what it would sell for today. And you just bought it today. And you're going to stay in it for 30 years. And the increase is 4%, like all my other questions. We are going to find out what your house is worth by the time you pay your mortgage off in 30 years from now. So 400,000 times blue button LN, 0.04 times 30. Close the guy, hit it. 1328046 and 77 cents. Your house is going to be worth 1,300,000 and change. 30 years from now, a $400,000 house is going to probably be worth more than $1 million if things go with the usual way that inflation does go. If you went to New York right now, couldn't you easily pay that kind of money for some place in New York? A little pokey apartment. Right? I bet you 30 years ago, that tiny little pokey apartment in New York wasn't 1,300,000. You probably could have bought that apartment for 400,000 30 years ago. That's what inflation does. It's a snowball that just keeps on rolling. Okay, so the next questions we're going to do are the, for want of a better phrase, time it takes to reach a certain value. Keep it nice and cryptic. So there is a formula that we have that is time it takes. So we are going to use this formula. It's the natural log of A, take away the natural log of P, divided by N, times the natural log of 1 plus, I'm going to use the R over N version rather than the I. So that's your formula when you get one of these. How long will it take for something to happen? So let's give you an example of what that would look like. In question 5, how long will it take you to get $8,000? If you started with $3,500 and the interest rate is 5% compounded daily. So you're putting 3,500 in the bank. The bank's going to give you 5% compounded daily, and you're going to take it out when it finally gets to being worth 8,000. And the answer to the question is, how long will I have to keep that money in the bank to achieve this goal? Well, it's an ugly formula. It's the natural log of A, take away the natural log of P, divided by N times the natural log of 1 plus R over I. I think I'm going to risk going over to the other big screen, but I'll put the numbers in. Natural log of 8,000, because that's what A is. Take away the natural log of 3,500, because that's what P is. Over, since it's compounded daily, N is 365. The natural log of 1 plus 5% divided by N, which is another 365. So that ugly calculation is going to tell me my answer. Right, I'm about to do it. Are we giving out positive vibes, everybody? Right, I'm going to hit this and it's going to be there and everything's going to be perfect, right? Positive vibes, go. Can you see that big calculator?
Yes.
We're on a roll, guys. Okay, now this horrible calculation that I wrote down that you no longer can see requires a lot of brackets. Even if you don't think it needs them, you put them in anyway. You start with a low bracket. And then you do the natural log, that's this button, 8,000. Close the bracket. Take away the natural log, 3,500. Close the brackets. And then close the brackets again. So if you look at it, I've got a bracket at the start and a bracket at the end. 2 around this guy, and 2 around this guy. Divided by, that's the top one. You put a bracket in again, and you write 365 times the natural log 1 plus 0.05 divided by 365, close the bracket, and that's to close the log button, and then close it a second time to close that. Now, if you scan through all those brackets, there should always be an even number. So if you can count 12 or 14, that's good. If you do count them and there's only 11, you've missed one, and that could well cause problems. Fingers crossed I didn't miss one. And the answer is 16.534. That's how many years you would need to put that money and leave it in the bank to turn that 3,500 into 8,000. But they don't want it that way. You've seen this before. They want 16 years, and then they want so many days. Can anybody remember how we found the days part?
We divided it by the 300. Were we doing it by the 360-day year now?
Yeah, we're doing 365 now. How do I turn that 0.534 years into days?
Divide it.
Not divide, multiply it. So here we go, clear that out of the way. 0.534 of a year times 365 gets you about 195 when you round it off. So do you notice that I had to multiply the decimal number of years by 365 days to get 194.91? Are we okay with that? Does that seem
Yes.
reasonable? Okay. Okay, so do you see how these times it takes to reach a certain value are going to use this ugly, whoops, bring it down again. This is going to be your go-to formula for those kinds of questions, right? Time it takes to reach a certain value. And that particular one I just did was, let me close this window off so I can tell you what number it was. That particular one, oh, there it is, was question 5. Now, question 6 is just like question 5. So you'll do it the same way. Now, question 8 is also like that, but I want to do question 8 because in this question, the way they did it is not helpful, actually. Question 8 gave you this formula. And this formula isn't really the one you need for the question. It's this formula. So bear that in mind. When you do question 8, it's just like 5 and 6. You are going to do the time taken. And it's going to be natural log of A, take away natural log of P, all over this guy. Now, in question 8, there's an A, a B to do. So let's start with A. And in question A, you start with $1,000. You want it to turn into $1,250. The interest rate is going to be 7%, and it's going to be compounded monthly. And we are going to find how long does that take, right? So it's going to be the natural log of what you end up with, take away the natural log of how much you started with. N is 12 because it's compounded monthly. The natural log of 1 plus 0.07 divided by 12. Now, if you use this formula, you get the correct answer. If you use this formula, you have got to solve a really, really, really ugly equation. And trust me, you do not want to do that. This is a much nicer formula because it does all the work for you. Don't you just plug and chug, right? You don't need to solve any equation. You just calculate what this is and you get your answer. And for time, I'm going to do it on my hand calculator here, right? So a bracket, the natural log of 1250, take away the natural log of 1000. Are we okay? Right. Notice I started and finished with a bracket. Divide, start with a bracket, type this in and finish with a bracket. So 12 times natural log, oh, I've already got a bracket, 1 plus 0.07 divided by 12, close the brackets, and finish with a bracket. And the answer I get is 3.197 years. You always get the answer in years, but that's going to become 3 years. And oh, they've changed the rules. I want to know not how many days 0.197 is. I want to know how many months 0.197 is. What do you think I multiply the decimal 0.197 by to convert it to months?
12?
Yeah, not a trick question. Times 12. And it's about, well, to the nearest whole number, it's about 2 months. Are we good with that one? You're not getting the same answer. Your face tells me you're not getting the same answer. If somebody was doing this with me, did you get that decimal when you did it? Otherwise, I'm just going to go back and do it. I got a nod, so I'm good. And that's the right answer.
Yeah.
Right. So let's do part B. In question B, the question's kind of vague. How long to double your money? Right. You still start with 1,000. But they didn't tell you that. But doubling your money means it turned into 2,000, right? And the interest rate is still 7% monthly. And we are still going to find how long it takes. So this time it's going to be the natural log of 2,000. Take away the natural log of 1,000. 12 payments, natural log of 1 plus 7% divided by 12. I'll try this guy, see what we get. Start with a bracket. Natural log of 2,000. Take away natural log of 1,000. Close an extra bracket. Divided, start with a new bracket. 12 times the natural log, 1 plus 7% divided by 12, close the bracket, close the bracket. And this time, 9.931 years, which is going to be 9 years. And well, let's find out. 0.931 times 12 is about 11 point, well, just 11 months really. So can you see that you can use this time till it takes to reach a certain value formula, right? This ugly, this guy here, right? To calculate how long it would take any amount of money to turn into any other amount of money, as long as you tell me the interest rate and whether it's compounded daily, monthly, or whatever. Are we good? Right. I want to show you a little trick. I don't think the textbook shows you this, but it is a kind of, it's a rule of thumb, right? It's not a perfect rule, but it's called the doubling rule. I've also heard it called the 70s rule. And that's nothing to do with the 70s. It's called the 70s rule for a totally different reason. And what the doubling rule or the 70s rule does is it tells you very roughly how many years it takes you for your money to double. So I'll give you an example. 5%. How long will it take at 5% for my money to double? Well, the formula says 5%, don't turn it into a decimal, 5% times the number of years is 70. So the number of years is 70 divided by 5. And that comes out about 12 years. Okay, how long do you think it would take 4%? Right, at 4%, how many years do you think it would take to double your money? Well, the number of years is basically 70 divided by 4. And 70 divided by 4 is what, about 17.5 years, right? 17 and a half years. Okay, let's do the one we just did a minute ago. I've lost the numbers for that one. Oh, this one. How long does it take at 7%? How long does it take for your money to double? And the answer is 70 divided by 7, 10 years. Hey, pretty good approximation, isn't it? 9 years, 11 months, 10 years, not a lot of difference. So if you were getting 1% interest, you know it'll take 70 years for the price of, for the thing to double. And if you got 10%, it would only take you about 7 years to double. Do you like that little doubling rule? It's our kind of rule of thumb. It's not used in a lot of questions, but it gets by for what it does. Okay, let me pause for a minute. Have we any questions so far? Is there anything you'd like me maybe to go back to, go over again? This is your chance. Okay, that's cool.
Could you just explain the doubling rule one more time, please?
The doubling rule, I'm trying to just be consistent with my names. Here we go. In the doubling rule, what you do is you multiply the interest rate by the number of years, and it always comes to 70. So if you rearrange the formula, the number of years it takes something to double in value is 70 divided by the interest rate. So there's the version of the 70s rule written like that. So if somebody says the interest rate was 12%, how long would it take me to double? Well, the number of years would be 70, And this is the only time I can think of where you don't turn that guy into a decimal. Right, you just use 12. So I go to my calculator and I'll do 70 divided by 12, and the answer I get is about, what, roughly 5.8. So it would take about 5.8 years. Right, so not quite 6, but a little bit more than 5. And if you wanted to, you could figure out how many months that was. So about 9 months, roughly. Does that help? Right. Now, that's the kind of calculation you would just do if you were wanting to do a rule of thumb, because it's not perfect. It's a little bit out. If you want to do it the real way, i.e. the accurate way, don't you have to do it with this much uglier formula? Right. Because there is going to be a difference between this and how long it takes you to double using this, right? There is going to be a difference. In the one that I did, wasn't about 1 month out. You know, the real detailed calculation said it took 9 years and 11 months, and this thing here said it would take you 10 years. So it was a month out, so it's not perfect, but it's darn close to perfect. Are we good?
Yes.
Right. Good. Okay. Question 10, we've covered. It's just future value. Question 11 is a future value. Question 12 is a future value. And the last one, and then we're finished B, and we can have a quick pause, and then we'll start C. Question 13. Did you know that in 2009, the American national debt was 11 trillion? Now, do you know that a trillion is that number? It's 11 million million. That's what a trillion is. It's 11 million million. So if you took the national debt in 2009, which is 11 trillion, do you know that you could find 11 million Americans, right? 11 million of you, and give every single one of you $1 million. Or if you want to get it in perspective, everybody in Washington State, man, woman, and child, could get $2 million each. That's how much you were in debt in 2009. Don't even go looking for how much in debt you are now. Do you know in the last few years how many trillions, you know, where's that $2,400 you got came from, right? That's debt, right? That is now part of the national debt. If you take that number and you divide it by everybody in America, which in this question A was 300 million of you. Let's see how much you all owe. Now I'm writing the numbers down with all the zeros. So here's 11 trillion. And here is 300 million. Now, I don't even know if my calculator can handle that number of zeros. I doubt it very much. So I'm going to have to figure out a workaround to figure out what this is equal to. And I'm going to do it like this. Can't I cancel these 3 nothings with these 3 nothings? I can cancel out these 3 nothings with these 3 nothings. So can't I just do 11 million divided by 300. Are you happy? But this calculation is the same answer as this one. At least I know I can hit that on my calculator. So let's put it in. 11, 1, 2, 3, 4, 5, 6, divided by 300. And the answer is 33, 333, 33. At least it wasn't a lot of sixes, because that would be an omen I do not want to see. In 2009, Tara, your portion of the American debt is $33,333.33. And if the Chinese, who are basically the people that hold almost the largest proportion of American debt, if they went and said tomorrow, I want my money back, have you got enough to pay it? That's your share. Not good. Do you know it's probably double that today? So in other words, the American debt is probably about 60,000 each man, woman, and child in America. That's how much debt we all have. Is that scary? Because it scares me. I am lucky. I am not an American, although I love being in America. So if the Chinese come and say, I want my money, I'm going back home to Scotland, and they ain't getting it off of me. So I thought I'd just throw that out. The rest of you, unfortunately, are eventually going to pay that. You know, you have to pay debt eventually. It just doesn't go away. Now, strange as it may seem, our politicians, it seems to me, haven't figured that out. Politicians don't really understand business or money, because virtually none of them have ever run a business or done anything successful with money, except write books and get money for doing that. Some of them think all you do is print more money. And then pay the Chinese with the money that you've printed. Seems reasonable. If you're Chinese, do you really want extra money that the Americans have just printed? Don't you want something that's worth something? If you double the amount of money in the American economy, you know what's going to happen? Everything will double in price to accommodate supply and demand. I'm just warning you right now, inflation is coming. Maybe not this year, maybe not next year, but it's coming. And so we need to have a pleasant thought to finish that question. I can't think of one. Okay, next question then.
With the gas prices this year.
Oh, you've already seen it starting already? Is that what you were saying, Jed?
With gas, the price has gone up.
Yeah, it wouldn't surprise me. Certain things go up more than others, right? Yeah, it's going to happen. Okay, part B. Ooh, now to depress us even more. The interest rate on our debt is 6%. I'm assuming that's what the Chinese ask for. And they want to know, what is the interest? Each second. Wow. Okay, I'm going to take 11 trillion. And that's P. Right? And R, right? And T, and that's going to be the interest. And I'm going to find out what the interest is in a year. And then I'm going to figure out, working backwards, how much that ends up being in a second. So 11 trillion, I'm missing some zeros. 11 trillion times 6% times 1 year. Okay. 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 6%. My calculator has got this guy. You're just going to trust me that the answer to that is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 66 billion. So in a year, we just have to pay 66 billion to the Chinese. That's just to cover the interest. That's not even reducing their debt, just to keep them happy, right? As long as you pay the interest, we're okay. 66 billion. Now, let's take 66 billion. And divide it by 365. And that ends up being 1808219,178, comma, comma, comma. I got all the zeros there? Let me check that. I think I missed a zero. 3, 6, 9, I did. It's 660 billion. Wow, that's scary. 660 billion, that means I need an extra zero, which means I need an extra zero here. So 18082191780. So 18 billion a day. So I'm taking 18 billion and 82,191,780 and I'm now going to divide it by 24. And then I'm going to divide that 24, because that's how much is in an hour. And I'm going to divide it by 60, and that's how much is in a minute. And I'm going to divide that by 60. And the final answer I got is 209,284. Who cares about the cents? The interest on the American debt is about 200,000 a second. Just to pay the interest, not to even touch the principal. America is going to have to come up with 200 odd thousand. It's probably closer to 400,000 now. There is nothing I can think of that is nice about that. So I need to get a joke, because I've depressed me as well. Okay, give me a joke. We're about to start our last section, but before we do that, I want to have a lighter mood. Anybody got a joke for us? Got nothing?
Nope, not me.
Okay, here goes. What did the green grape say to the purple grape?
No idea.
Breathe.
Oh, okay, I got it because he's turning purple.
That one took some time, okay. Oh, I've got to tell you some of the really, really stupid ones. These are so bad I like them, but not everybody gets them because they are so bad. What's got 6 legs, is green, and if it fell out a tree, it would kill you? A pool table.
Oh my god.
Why don't you play cards in the jungle? There's too many cheetahs.
Oh,
No. Go on, one joke. Somebody must have their 4-year-old brother told you a really silly joke or something.
I have a joke.
Tara. Oh, good. What you got, Tara?
Where do pirates eat? I don't know.
I don't know.
Arby's.
Oh, pirate jokes, Arby's. I have pirate jokes. Okay, what's a pirate's favorite letter?
Arr.
C.
Ah,
Correct. It's not R. Their first love has always been the sea. Okay, that one took a bit of thinking.
Okay.
Okay, one more of those.
I
This
got
is
it. I
quite
got
a
it.
long one, but yeah, you're doing the steps up to heaven thing, aren't you?
yep.
You got the first one. Okay. This one's quite a long one, but I like it. It's about pirates. And after that, we'll get started on the next section. Because even if you don't, and I think you probably do, don't we need a little break in our brain? So
Yeah.
we're not just doing over and over the same stuff. So this little boy loved pirates, was crazy about pirates. You know, like some kids love dinosaurs, he loved pirates. And he was walking along the beach one day and he saw a pirate at the end. And he runs over to him and he's dead excited. And it's like the movie Pirate. He's got a peg leg, he's got the pirate clothes on, he's got a parrot on his shoulder, he's got a patch in the eye, he's got a hook, he's got the hat, and he's got, the funny hair, the lot. Perfect. Perfect pirate. And the little kid is jumping up and down with excitement. And he finally goes to the guy and says, "Are you a real pirate? Honestly, are you a real pirate?" And the guy goes, "Ah," says, "I'm a real pirate." And the kid was, "Oh, that's cool." And he looks him over and he looks and he sees his peg leg, and the little kid says, "How come you've only got one leg? How come you've got a wooden leg?" And the pirate says, "Well, I was out at sea one day and there was a big battle and a cannonball blew my leg off and I got a peg leg." The little kid went, "Wow, that's cool." And the kid looks at him a bit more and he says, "How come you've only got one hand? How come you've got a hook?" And the pirate says, "Well," says, "I was out at sea one day and there was a big battle and a cannonball blew my hand off and I got a hook." And the kid went, "Wow, that's cool." And he looks at him and says, "How come you've only got one eye? How come you've got a patch on your eye?" And the pirate says, "Well, I was out at sea one day and a seagull pooped in it." And the little boy says, "You don't lose your eye just because a seagull pooped in it." And the pirate says, "You do when you forget you've got a hook."
That's a good one.
I got a thank you from a little voice. Who was saying thank you?
I heard that too, actually.
Somebody's. Well, thank you to whoever said thank you. That made my day. Did you like my pirates joke, or was it not your favorite?
That was a good one.
That was a good one.
Okay. Yeah. If we can hold it, just bear in mind, I think I have to log back in again because I've been so long away. Yeah, you're still there. It's a moment of dread. I thought I'd lost you. We have one more section to do in money, and the good news is that's money finished with, right? The finance one. a lot of people, not everyone, but a lot of people find that this is the hardest stuff that they do in this class. Now, I'm not saying that's true for everyone, but that might be a pleasant thought, that this might be the hardest thing in this class. So if you're coping well with this, you're probably going to cope well with the rest. What makes it hard? Really big, ugly formulas and lots of them, right? That's probably what makes this section so difficult, right? You got to know which formula to use, and then the formulas are pretty messy, most of them, right? So we are now on to our last section in money, and I'll just write down the heading. Math 107, of course, and it's chapter 11.2. So if you want to look up your ebook and get more on it, and it's got a general heading, I'm calling it installment buying. So this is a version of question 1. Actually, it's probably easier to show you them because the first few questions are sort of a multiple choice. There we go. Now it says estimate. So it doesn't mean you guess, you do a reasonable assumption. And it says estimate what would be the right answer. If you purchase $2,400 item and you pay for it with monthly installments for 2 years, which of these numbers do you think you should pay? Now I'm doing a little calculation right now to show you what I would be looking at. And okay, I'll not break my rules. I'll do it in my head.
We can.
2 years.
Yeah, you're still on you again.
It's got no. No,
Yeah, it's not working.
that's
again.
not allowed. It's not working again. Okay. Is it working now?
I'm afraid not. Now it is.
Are we good?
Yeah, we're good.
Okay, so 2 years, 12 monthly payments, that's 24 payments. Now, $2,400 divided by 24, I could do that in my head, right? Would you agree that's $100 a month? But the correct answer is not $100 a month. Because in real life, if you borrow or pay something, don't you have to pay extra? Don't you pay an interest, a finance charge? So I would assume that it would have to be more than $100 a month. But if I wasn't paying interest, it would be 100, but I know in these questions, that's not the way it works. If I pay off my credit card balance each month, right? So imagine you got a credit card, but you do what you should do, but to be honest, very few people I know, including me, do it. Shouldn't you pay off your credit card so it's zero? In other words, you don't pay any interest. And the way credit cards work is that they're very high interest rate, and every month you pay the interest plus some extra to reduce it. But if you clear it, you get no interest. It then says, if you do that, what's the most important cost factor with my credit card? Is it the APR, the interest rate on the credit card? Well, not really. If you always pay it off, wouldn't that not matter? Can you have a credit card with 200% interest rate, but if you always pay it off, aren't you never going to pay it? It's never going to be a problem. The grace period is just the 30 days that the month lasts for. It's really not that helpful. Isn't the main cost going to be your annual fee? So if you were thinking about getting a credit card, you have to be really serious and you have to understand what you're going to do with it. If you say, I guarantee I'll always be able to pay it off, right? I guarantee my credit card is always going to be clear at the end of the month. No exceptions. I know I'm going to do that. I can guarantee it. Then do you know the best credit card for you to get is the one with 0 annual fee or a very small annual fee, because you won't pay anything except that. Does that make sense? Right. Now, on the other hand, if you really know that that's not the way things work, that you're always going to have money on your credit card, right? Because you're never going to be able to clear it off right away. You're probably going to be working with it. In that case, wouldn't you look for a credit card with the lowest interest rate? Because that would probably make your life, you'd pay less because of that. I think this is a little bit unfair, but I'm going to do it the way they say it. We're estimating, but do not calculate. $1,210, an interest rate in 9.8%, and it's going to be for 4 years, right? So I'm not going to use 1210 because that's too hard. I'm going to pretend it's 1,200. I'm not going to do 9.8%. Can't I just pretend it's 10%? Because those I can do in my head. $1,200 at 10% is $120 a year. For 4 years, that's 480. Do you see that that number's the closest? You see how I did that in my head? Are you comfortable with how I did that? I just made it nice round numbers and tried my best to guess it. Now this one has no calculation. I guess it depends if you've even got a credit card. Oh, it's not a credit card, it's an installment roll, right? Which of these three would you think would be a reasonable interest if you were buying a car, right? A 3-year installment would be paying off your car in 3 years. A 1%, an 11%, or a 36%. What would you think would be a realistic number? Anybody bought a car lately? Do you know what your interest rate was?
11.
I agree with you. It's probably 11. And if you have to buy a car and the interest rate is 36%, you have got the worst credit rating in the world, because that's the only way you're going to get a car. So see those adverts that guarantee you a car? Ever seen them? I don't care what your credit's like, we'll get you that car you want. The reason you're going to get it is you're probably going to pay some ridiculous interest rate like that. In other words, it's going to cost you a lot more money. I have seen 0% and 1% on cars. And in today's interest rate, that actually can happen. It's not typical, but it can happen. If you've got really, really good interest, really good credit rating, they might give you 1%. Because you are not at risk. In fact, you could probably pay it off, you just didn't bother. You might get 0% interest rate. I've seen that. I've even seen 0% interest rate for 2 years or something, that kind of thing. Do you know how they fiddle that one? They make you pay more for the car. So they would have charged you 12,000 for the car, but they charge you 13. But they call it 0% interest rate, so you think you're getting a deal. You see how that works? It's a little bit sneaky, but that's really how they do it. But in general, I would agree 11 is the answer. Of course, do you know you get 5 guesses? So if 11 doesn't work, won't you try 1? And if 1 doesn't work, you'll try 36. So you'll eventually get it. So although these questions might seem a little bit unfair, because you get 5 guesses, aren't you? You're safe, right? You're not going to lose points. Okay, we're still in the estimate world. If you want to purchase a car and it's $10,000, what would be a reasonable offer?
$9,000.
5? Is that what you said?
9. The option was 9,
Oh,
10,
9.
or 11. If you're paying cash, usually
Right.
you can talk them down.
Right. Okay. You could probably talk them down. Now, the thing that we need to look at here is this word here that you might not be aware of. The sticker price. There's a price on the window when you go and look at the car, right? It'll tell you this car, well, you can buy it for 12,000, right? That kind of thing, right? And then there's the price that the people who are selling the car, that it cost them, right? It cost them 9,000 to buy it, right? Now, if it's a sticker price was 10,000, you might be able to get 9. But if that's how much the car cost them, they're not going to sell it for 9, are they? They're going to lose money. They're going to sell it for 11. So you could ask, you could say, I'll give you 9, but if that sticker price means what they paid for it, they're never going to sell it for 9. They're just going to say, I'll wait to the next person. You know, I need to make a profit here. I'm not going to sell it for less than I bought it. I mean, that's how you go out of business, right? If you do that too many times. What do you think a reasonable APR for a credit card is? So what do you pay interest per year? What would you think would be a reasonable number?
8%.
8. The little kid said 8 too. Well done. Is that your kid, Tara, that's joining in? She is. Well done.
Yes, that would
You
be a
got it right.
6-year-old.
That's a 6-year-old. They're precocious and cute. So 8%. I would say if you could get a 1.8%, you better be Bill Gates, because I don't know anybody else who can get that interest rate. And if you got 42%, it's because you've got the worst credit in the world. So not only are you buying a car at 36%, right? You're paying 42% on your credit card. Not good. In fact, that's an exaggeration. I don't think anybody in their right mind would pay 42%. Although payday loans could easily be that high, but that's not a credit card. When using the average daily balance method for the month of October, do you know what the average daily balance is? It's a credit card term. Does anyone know what it means? Average daily balance. Okay. Every single day of October, your credit card has money on it, right? So maybe it's got 400 and then you buy something at 50. So 2 days later, it's now 450. And then you buy something for 100 and the following week and now it's 550. Can you see that through that entire month, doesn't the amount in your credit card change as you buy stuff? And maybe you'll pay off $200, right? You pay 200 your credit. So sometimes it also goes down. So what the average daily balance does is it just takes all 30 days or 31 days, whatever it is in the month, and it calculates that into your thing. So if you want to know what the daily balance is, how many days are there in October?
31.
And so that is the fraction that you would use in your daily balance. Okay, you have $955 in your credit card. That's getting a bit big. You pay 50 down, right? So I guess it's gone to what, 900 what, $905? Let's call it 900. And the interest rate is 12%. Oh, but that's per year. So wouldn't that just be 1% a month? And if you put that together, you get that answer, or you get that answer. I'm not going to tell you that one. There's the same question again. I won't tell you that one. Let's try this one. Finally, I get to use my calculator. Convert this credit rate to the annual percentage rate. What do you think you do to find 2 3/4% a month? How you figure out what that would represent in a year? Just tell me the calculation if you can think what it might be. Well, it's definitely 12, isn't it? Like 12 months in a year. And you're going to be paying, so times 2 3/4, I would probably turn it into 2.75 because it makes it easier to do it. And 12 times 2.75. Wow. I'd get shot of that credit card as soon as you could. Right? Pay the damn thing off, get a different one. Because at 33%, that's rough, isn't it? That's a lot of money. A high interest rate. Well, let's look at the next one. This guy, daily. Well, if I want to know what the APR of this one is, 0.04089. Since it's daily, in a year you get 365 of them. Do you think that one's going to be better, meaning a smaller number than 33? Or do you think it's going to be even worse? What's your gut feeling? I'm typing it in while you're thinking.
It's smaller. It's 15.
I would agree with you. It's about 14.9, but 15 is good enough. It's about 15%. So if this was real life, if I had this credit card, wouldn't you do the best you could ever do and pay it off? And then I'd get this credit card. Because couldn't you use it and pay less interest and get all the benefits? Now, what credit cards love to do is sucker you in to using their high interest credit cards. Because you know, if you have 4,000 or 5,000 on your credit card, isn't it really, really hard to get it down to zero? And it's just financially difficult to do that. So once they've got you, aren't they going to keep you at that 33%? Because the interest will be so big, most of your money will be just to get the interest covered, right? You won't be able to nibble into the rest. And it'll take you forever and a day to get out of it. How do they sneak you in? Have you ever seen an advert for a credit card? 0% interest for the first year. You ever seen adverts like that? Well, why are they doing that? They want you to spend the whole year using that credit card, right, without any interest on it. And you're going to think, hey, this is easy. It's like getting money for free, right? You buy something, you don't need to pay it off. Yeah. But at the end of that year, don't they then hit you with a 33% interest rate? But you have already got 4,000 on their card, then you can't get rid of it. You see the sneaky way that can happen. So, you know, be very astute when you do credit. Credit cards should not really be your main way of buying stuff, right? Until you get rich, right? Think of buying stuff with money. It's just safer, right? Don't try buying stuff with credit cards, because then you end up getting into a really bad place if you're not careful. And oh, God, the time shoots by when you're enjoying yourself. Okay, I have a little bit of setup to do. I want to show you the beginnings of a credit card payment. How you can figure out yourself how much you're going to end up paying on interest on your credit card, right? So the question that I'm going to do it with we have a balance of $850. Good, that's not a lot. We have a payment. So you pay $800. Well done. Okay, that's good. The interest rate is 18%. And this particular month, because you get interest on your credit card every month, in this particular month, it's a 30-day month. So let's figure out where are we? They're saying calculate the monthly finance charge. That's just another way of saying calculate your interest. So let's see what it was going to be. If you subtract that away from that, don't you have a balance of $50? Right? Now, I'm going to assume that I paid that right at the start. So my average daily balance is going to be $50. Now, my interest rate is 18%, and then it's time. So it's basically PRT. $50, 18%. And the time is 30 out of 300. Oh God, do you think this is going to be a 365-day year or a 360-day year? Because they keep changing it on me. I think it's 365. I'm going to assume that it is. So $50, 18%, the fraction of the year, 30-day. So if I go here and I put that all in, I have $50 times 0.18 times. Now, if you want to do that, guy, if you put a little bracket around it, you can actually let the calculator do it all for you. So brackets, 30 divided by 365. You see, it makes life a little bit easier. And I'm going to be paying about 74 cents. And that is assuming that I paid it at the start. Now, let's suppose that I didn't pay it until the last day. And that means that I'm going to have $850 times 18% times 30 over 365. So can you imagine you waited to the end of the month and then you paid it? Do you know if you did it that way? That's going to be your average daily balance, right? It was 850, right? All the way. The fact you paid 800 doesn't matter until the following month. So what's going to happen if you did it this way is you're going to have $850 times 18% times 30 days again. And if it's calculated that way, to see you now pay not much interest. Now you might say, oh, it's not a lot of difference, which I agree, it's only $12. It's not an awful lot of difference. But find out when you've got a credit card when the payment date is due. So let's suppose it's the 14th, right? Every month, start to the finish, right? From the 14th of the previous month to the 14th of this month, right? That's the monthly period, right? If you can find that out, pay it off before the monthly period is over so that you end up with this number. If you pay it off after it, you'll end up with this number. Can you